we will see the photons concept. Photons. In radiation matter interaction, radiation act as if made of particles called photons. Sunlight is coming to a wall in the form of waves, and it strikes the wall. The moment it strikes the wall, its behavior changes and it acts like a bullet, a particle which is having velocity. What is the name of that particle? That we have invented and given it a name, photon. While that is subatomic particles, they have nomenclature electron, proton, neutron. On is the last two letters. So this was a given name, photon. Photo, light, on for particle. So this is particle of the light which strikes a matter. At that time, its behavior become like a material when the light interact. So in radiation matter interaction, the radiation, that is light, act as if made of particles. These are called photons. Now, what is the property of this photon? Photons are thought to be packets containing energy. Okay. Photons also have frequency and wavelength. The light, these photons are having both the natures. They have got momentum, they have got mass, they have got energy, they have got frequency, they have got wavelength, and they have got speed. So they also have frequency and nu and wavelength lambda. Energy of the photon is decided by its frequency. This is the formula for energy of the photon. Okay. If nu we write as c upon lambda, this will be hc upon lambda. Photon also have momentum. What is the formula for momentum? Momentum has a general formula, energy divided by velocity. If we have this energy and divide by velocity, energy divided by velocity. Velocity is what? Velocity is nu into lambda. Nu cancel, h upon lambda is the momentum. So, how much is the momentum P? H upon lambda. We can say h nu upon velocity of the light. That is equal to h nu, velocity is equal to frequency into wavelength. So this is equal to h upon lambda. This is momentum, h upon lambda. So now see the third property of the photon. When we increase the intensity, what happens to the photon? Answer, increasing intensity means what? Changing the bulb of 100 watt to 200 watt to 500 watt, we are changing intensity. What is the effect on the photon? Answer, the number of photons given by 100 watt will be less and the number of photons given by 200 watt will be double in quantity. But nature of every photon will not change. Why? The color is not changing. The frequency is not changing. So if frequency is not changing, color is not changing, then energy of each photon is not changing. So when we change the intensity, energy of each photon do not change, but number of photons multiply. That is what happens when we change intensity. So let us write that. See, third property. Whatever is the intensity, that means intensity less or more, all the photons of a given frequency have same energy. So whether intensity is 100 watt, 200 watt, 500 watt, each and every photon, individual photon, will have same level of energy, and that depends upon its color. that depends upon its frequency, and it will have the same momentum. All the photons are same in momentum, all the photons are same in energy. Whether it is a light intensity bulb, light intensity, or it is a higher intensity, the energy of individual photon remains same, and every photon has got the same level of energy. Next, by increasing intensity. When we increase intensity, then what is the effect of photon? The number of photons increase. The number of photons increase, but energy of the individual photon remain constant. And if the number of photons increase, the number of electrons increase, and if the number of electrons increase, the current will increase. That is why when we increase intensity, the saturation current goes on increasing. Here we are keeping the intensity constant, frequency we are changing. Intensity is constant for all the three. Therefore, current remains same. Photocurrent remains same for all the three frequencies, because intensity is same, because intensity is made of number of photons. So, frequency 1 was giving 1 lakh photons from 100 watt bulb. Frequency 2 again 100 watt bulb, 1 lakh photon. Frequency 3 again 1 lakh photon. So, current from all the three will be same. That is why here saturation current is same. Why here it is different? Because we are changing intensity. We are changing intensity, keeping frequency same. So what's happening? When we change the intensity, the current increase, and that we have done in our earlier also, intensity versus current. So intensity increase, current increases. Now, last, all photons travel with the same speed. Photon having less kinetic energy, more kinetic energy, all travel with the same speed. They automatically adjustment is done with their momentum so that the speed remains same. And what is the speed of a photon? That is speed of the light, 3 into 10 to the power 8. So it hardly matters whatever is the kinetic energy of any photon, what is the frequency of the photon. The velocity of all the photons is velocity of the light. Now, next point is, next, number 6, frequency of photon give it a definite energy, and that energy we name as color. So please remember now onward, the color of the light is not due to its wavelength, it is due to its frequency. And the proof of that is, when it enters a different medium, the color do not change. We see in the water, in the glass, when we enter the water and see a green light coming from outside, it also appears green inside the water, though wavelength has changed. But white appears green if the wavelength has changed? Answer is because the frequency has not changed. So, who is responsible for color? Answer, frequency is responsible for color. So, frequency, color. In different medium, the wavelength changes, and that brings the change in velocity. So, if wavelength becomes smaller, number of frequency remains same, but wavelength has become smaller, so total distance will become smaller. And the last, rest mass. This is very important. Rest mass of the photon is 0. That means it may have a mass when it is traveling with a very high speed, and we can assume it has momentum, it has energy when it has motion, in motion. But the moment it strikes a metal, its velocity becomes 0, and how much its mass becomes? Mass also becomes 0. So when we weigh that metal after absorption of sunlight, we find there is no change in mass. Why there is no change in mass? Because all the photons have their velocity as 0. And once the velocity has become 0, its mass has become 0. So again, when the photon goes out, it has momentum, it has energy, it has mass. But when it comes to rest, mass is 0. This is what relation of Einstein with the mass, that mass under motion is equal to rest mass divided by 1 minus v square upon c square. So when velocity, this you multiply here, bring the velocity equal to velocity of light, so m naught will become 0 for photon. So these are certain features of photon which the student should remember, and that gives the knowledge of the quantum physics initially, that how we had a quantum of energy which is photon, and how these photons behave and what are their properties. But with this experiment, another thing we are supposed to study, and that is failure of the wave theory. How wave theory failed because of this experiment, this we will see in the next lecture. Thank you.